Hi KCET 2025 aspirants. So we are just left with few days for our KCET examination and now it's high time to practice questions, right? So in today's video we are going to discuss top 30 questions from the chapter D and F block elements, okay? So I have already completed the one shot of D and F block in our master stroke series. So you can just go and revise all the concepts and then come back here and do question practice, okay? So these are all like a type of previous year questions, like not all our previous year questions because I have already done a dedicated video for previous year questions. We'll make a separate playlist for you, so do not worry. And now moving to the first question here. The number of moles of KMnO4 that will be needed to react completely with 1 mole of ferrous oxalate in acidic solution is. So this question is little bit, I'll say, tricky, okay? And how to assume, so please understand it properly. So 1 mole of MnO4 minus if you have taken. So what is happening? If MnO4 minus in acidic medium, you know, it oxidizes, it gets reduced to Mn2 plus, right? Mn plus 7 to plus 2. And then because it is a reduction, we have a gain of 5 electrons, okay? Then we have 4 water to balance the oxygen, and then I have here 8 H plus, okay? I have here 8 H plus. Now what is the question? If you see this, in this ferrous can also get oxidized and oxalate can also get oxidized. So based on what the question is asked, you have to judge based on the options here. So if I just consider ferrous, so ferrous is like this, Fe2 plus will get oxidized to Fe3 plus with 1 electrons, okay? So now here we have multiplied with 5 so that the number of electrons becomes same, and I will get equation like this, that is 5 Fe2 plus is equal to 5 Fe3 plus is equal to plus 5 electrons. So now what happens? You can cancel this one and this one, okay? When you cancel these two, we get a reaction here, that is 8 MnO4 minus plus 5 Fe2 plus, okay, 8 MnO4 minus plus 5 Fe2 plus 8 H plus gives me Mn2 plus 5 Fe3 plus, okay, plus 4 water. Okay, so if I see this reaction, I am saying that 1 mole of MnO4 minus is oxidizing 5 moles of Fe2 plus, right? 1 mole of MnO4 minus is oxidizing 5 moles of Fe2 plus. Then if I see that for 1 mole of Fe2 plus, see, I can write like this, 5 moles of Fe2 plus is oxidized by 1 mole of MnO4 minus. Then 1 mole of Fe2 plus will be oxidized by 1 by 5 mole of MnO4 minus, right? But if you see the question is not having any option regarding 1 by 5. So that means it is talking about the oxidation of C2O4, that is oxalate, and not Fe2 plus, okay? So now if I write that one, so you can understand like this, just a minute. Yes. So now you can check this, that oxalate ion C2O4 2 minus gives you 2 CO2, okay? So now here if you see, it is plus 3 and this is plus 4, okay? So plus 3 to plus 4 is having 1 electron, right? The oxidation of 1 electron is taking place. So what I will get, there is a loss of 1 electron. So oxidation, right? So loss of 1 electron here, okay? So now this is for 1 carbon, but here we have 2 carbon, so definitely it has to be for 2 carbon. To make this balance now, the number of electrons should be same. So this I'll multiply with 2 and this I'll multiply with 5. So what I will get here, 2 MnO4 minus, okay, and here I'll get 5 C2O4 2 minus. So what I can say that 5 moles of C2O4 2 minus can be oxidized by 2 moles of MnO4 minus. So I will just erase this part. So we are not talking about Fe at all. So if the question is regarding 1 by 5, then there will be no 2 by 5 in the option. So you can see here that 5 moles of C2O4 2 minus is oxidized by 2 moles of MnO4 minus. Okay. Now 1 mole of C2O4 2 minus will be oxidized by 2 by 5 moles of MnO4 minus. Okay, so now this one will give you the answer 2 by 5. So the correct answer is option number B. Let's see the next question here. The equivalent weight of KMnO4 when it is used as an oxidant in neutral medium. So if you see in neutral medium, what happens to MnO4? So it gets converted, that is MnO4 minus to MnO2. Okay, so here it is plus 7 to you will get plus 4. Right, so plus 7 to plus 4, it is 3 electrons. So I can say that there is a gain of 3 electrons. Right, so reduction is there. So the equivalent weight will be molar mass divided by n factor, that is 3. So the correct answer will be option number C here. Next, which of the following transition element shows the highest oxidation state? So we know manganese has a oxidation state of plus 7. So that is the highest one. So option number A here. Next, if KMnO4 is reduced by oxalic acid in an acidic medium, then the oxidation number of Mn changes from. So it is reduced by any element in acidic medium, manganese oxidation state changes from plus 7 to plus 2. Okay, so MnO4 minus gets converted to Mn2 plus in acidic medium. I hope this is clear and all of you will remember this one. Next, zinc and mercury do not show variable valency like D block elements because. So you know one of the most important property of the D block elements is they show a lot of variable oxidation states. And the reason for this is the gap between the n-1 D and ns electrons is very less, so all of them can participate in the bond formation. But in case of zinc and mercury, the case is different. They do not show multiple variable oxidation state, and the reason for that is they have their D shells are complete. So if the D shells are completely filled, they are very stable, they won't participate in the bond formation. So only 4s orbital will participate. So that is why there is no variable oxidation state in zinc and mercury. Next, the element with the electronic configuration 3D10 4s1. This is one of the anomaly, if you remember, copper and chromium. So this is copper electronic configuration. Answer is option number D. Next, which of the following statements about the interstitial compounds is incorrect? So if you remember what is interstitial compounds, I have already discussed this in the master stroke series as well. So when the compound is formed, there are some gaps in between, right? In the gaps, if small elements like hydrogen, carbon, nitrogen occupy the voids and improve the properties of the metal. So these are called as your interstitial compounds. So first of all, interstitial compounds, they retain the metallic conductivity. Yes, so at first let me tell you the properties. So they make the metal hard. Okay. Then they increase the melting point and boiling point. Then third, what we have next is they are chemically inert. Okay, when these elements are added, they do not change the chemical properties anything. Okay, chemically inert and retain the metallic conductivity. Okay, so these are the properties of interstitial compounds. Next, they retain the metallic conductivity. They are chemically reactive. No, they are chemically inert. So the correct answer here is option number B. Next, which one of the following is an example of non-typical transition elements? So non-typical transition elements means they are a part of D block elements, but they do not show the property of transition elements. So if you all remember, this is zinc, cadmium and mercury. These are also called as your pseudo transition elements. Why? Because they do not have incompletely filled d orbitals. Okay, do not have incompletely filled d orbitals. Okay, now coming to next question number 9. Compound that is both paramagnetic and colored is. Okay, compound that is both paramagnetic and colored. So for both paramagnetic and colored, we need one thing, that is unpaired electrons. If unpaired electrons are there, then it will be both paramagnetic as well as colored compound. So let us check the oxidation state in all of this. So K2Cr2O7, so this is +2, right? For each of the potassium it is +1, so 2 potassium means +2. Then here I will put 2x, and this is oxygen is -14 is equal to 0, so I will get x is equal to +6, means chromium oxidation state is +6. Next, if I see here, this is 2 is there, right? So this must be the complex B, must be like this, it must be NH4. Okay, let me just write down. So NH4 charge is +1, right? So we have 2, so it is again +2. Ti I will take x, chlorine is -6, so I will get +4. Okay. Next, if I see VOSO4, sulfate, together you can consider it as -2. Oxygen is also -2, so I can say x -2 is equal to 0. So this is +4. Now here we have 3, okay, plus x, then we have -4, okay. So 3 plus x minus 4 is equal to 0, and copper here it will be +1. Okay, copper will be +1 oxidation state. So now if you see chromium electronic configuration 3d5 4s1. If I take +6, chromium in +6, okay, then I will get argon. Okay, all the 6 electrons will be removed and we will get argon configuration. So here there is no unpaired electron, so it will not be paramagnetic or colored. Next, if you see Ti +4, so scandium titanium, titanium configuration is also like this, argon 3d2 and 4s2. And if I see Ti +4, it will also have only argon. Here also no unpaired electron, so this one will also have no unpaired electron, so no color and no paramagnetism. Vanadium, if I see +4, scandium, titanium, vanadium. Vanadium electronic configuration is 3d3 4s2. And if I have vanadium in +4 state, from 5 electrons 4 will go, I will have 3d1. So there is one unpaired electron, and this one unpaired electron can show paramagnetism, can undergo dd transition and give you color. So the correct answer for this question will be option number C here. Okay. Moving towards the 10th question, which of the following is the correct configuration for iron? So this is very simple question, you should be remembering. So for iron it is 3d6 4s2, okay. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and then 3d6, right? What is the difference here? Wait. Okay, here both the options are same, so you can see B and C, but the thing is 3d6, 4s2 is the correct option, okay. Next, we have here potassium permanganate. So potassium manganate, okay, not permanganate. K2MnO4 is formed when? So K2MnO4 is the formed from MnO2 first step, and then K2MnO4 is converted to KMnO4. If you have learned the preparation process, then you will be knowing this. So that happens when manganese dioxide is fused with potassium hydroxide in air. First we get potassium manganate, okay, then after you do electrolysis, then you get converted to permanganate. So the correct answer here will be option number B. Next, a compound of metal ion Mx plus has a spin only magnetic moment of √15 Bohr magneton. The number of unpaired electrons in the metal are. So if I have √15, okay, so that must be like this. From if I have taken n into n plus 2, okay, that will be √15. So if I have 3, this one, so root over of 3 into 3 plus 2, so that is equal to √15. So n is equal to 3 here. Okay, n is equal to 3 here. So what is the number of unpaired electrons? D, option number 3. Okay, which group contains ions out of colored ions out of this one? So you have to find colored ions. Again, for colored ions, what I need unpaired electron, right? So which are there where we have unpaired electrons? So copper 2 plus, if you remember, copper 2 plus is having D9 configuration. So if you have remembered the configuration, you will be able to solve the questions quickly. Otherwise, you will waste time in writing the configuration and all. So copper 2 plus is D9, so it will have one unpaired electron. So yes, it has unpaired electron. Ti plus 4. Ti plus 4, scandium titanium, right? We have just seen now it is 3d24s2, so no unpaired electron, so it will not show color. So whichever option is having 2, I can eliminate all of them, right? So easily the first option, that is the second option 1, 3, 4 will be colored. But let me show you also, cobalt 2 plus is 3d7, right? So 3d7 will have 3 unpaired electron. If you draw like this, yes, 1, 2, 3, 4, 5, 6 and 7. So 3 unpaired electrons. Next, the fourth compound here is what? Fe2 plus, right? Fe2 plus is having the configuration of 3d6, right? So 3d6 is having 4 unpaired electron. So the compound 1, 3 and 4 are having unpaired electrons. So that is why they will give you colored complex, and option number B is the correct answer. Next, which one of the following ions has the highest magnetic moment? So highest magnetic moment again depends on the number of unpaired electrons. Okay, more is the number of unpaired electrons. More number of unpaired electrons means more magnetic moment. Okay, more is the number of unpaired electrons, more will be the magnetic moment. So now if you see here, Cu2 plus, okay, Cu2 plus is how much? 3d9. Okay, so number of unpaired electron here is 1. Scandium titanium, titanium is having, titanium 3 plus also has d1 configuration, so 1 unpaired electron. Nickel 2 plus is having 3d8, right? So 3d8 means if I draw 3d8, so I just don't want to waste your time by doing all these things, like very detailed explanation, but yes, some students might be there, so I am doing for them as well. So n is equal to 2, 3d8 here. Okay, so number of unpaired electrons is 12. Mn2 plus is d5. So now you might be thinking how I am getting this. So if you have remembered the electronic configuration properly, these questions you can solve within seconds. Okay, so 3d5 is your what? d5. So I have 5 unpaired electrons, so magnetic moment will be 5. So correct answer is option number D here. Next, an element in +3 oxidation state has the electronic configuration Ar3d3. Its atomic number is, okay. So if you have an element in +3 oxidation state, so you know argon is having atomic number of 18. Here we have +3, right? So 18 plus 3, 19, 20, 21, and +3 oxidation means 3 electrons have lost, means it was having already 3 electrons, so that will give me 24, and the atomic number element is chromium, so option number A here. Next, in the dichromate anion, what is the bond structure? So if you remember Cr2O7, so it is like this, okay. So you have like this Cr2O7 2 minus, okay, Cr2O7 2 minus. So here you can see that these bonds undergo resonance, okay, this undergo resonance, this undergo resonance, here also they undergo resonance, but there is no resonance here, okay. So I can say that these 6 bonds are of one type and these 2 CRO bonds are of different types. So 6 CRO bonds are equivalent in nature, clear? Next, which of the following compounds of manganese is amphoteric? This is also a very good question. So if you remember, lower oxidation state is generally basic, okay. The medium oxidation states are generally amphoteric and the higher oxidation states are acidic, right? So if I see here Mn +4 state, okay, here it is again +2, this is +3, and this is +7, okay. So these are your basic. +4 is somewhere which is the basic amphoteric one, so option number D here. Next, in context with the transition elements, which of the following statements is incorrect? In the highest oxidation state, the transition metal shows basic character and forms cationic complexes. No, when I just now I told you in higher oxidation state, the element behaves as a acidic nature. It is acidic in nature, okay. So that is why this statement itself shows basic character is incorrect. So option number A is the correct answer. Next, ammonium dichromate is used for some fireworks. The green colored compounded blown in the air is. So when you when you decompose the ammonium dichromate, you can see a compound Cr2O3 plus nitrogen gas plus water. Now this green color powder which is blown in the air is due to this Cr2O3. So correct answer is option number B. So please remember these reactions and note down this one. Okay. Next, mic metal. So this is very important question. So mic metal is a alloy of lanthanoid metals where you have 95% of lanthanoids, 5% iron and some other elements are present in trace amount. Next, which of the following statement is not correct? Again, you have to find the incorrect statement. Lanthanum hydroxide is less basic than lutetium hydroxide. So if you remember, in lanthanide contraction, one of the major consequence of lanthanide contraction is the basicity decreases along a period, right? So we have here lanthanum, okay, and the last element here is lutetium hydroxide. So we have studied that according to lanthanide contraction, the basicity, right, along the period the basicity decreases. Okay, along the period the basicity will decrease. So what I can say, lutetium will be more basic than lanthanum hydroxide will be more basic than lutetium hydroxide, but here the statement is given lanthanum hydroxide is less basic. Okay, it is OH3, less basic, so that is why it is incorrect. Option number A is the correct answer. Okay. Next, in lanthanide series, ion radius of Ln3 plus ions also decreases. Yes, whether it is Ln or Ln3 plus, along the period the size will decrease. La is actually an element of the transition series rather than the lanthanoid series. Yes, this is very important statement and very important statement. Remember, lanthanum, okay, you have 3D series, 4D series, 5D series. Lanthanum is the first element of 5D series. Okay, from the next element the lanthanoid series starts. Okay, so it is actually a transition element, but since the previous element was lanthanum, the name is given as lanthanoid, but it is actually a part of 5D series. Okay, atomic radius of zirconium and hafnium are same because of lanthanide contraction. Yes, this is also a consequence of lanthanide contraction. Next, yes, this is important. Lanthanoids are 14 elements in the 6th period. Yes, so if you see 3D, 4D and 5D. So 3D is actually 4th period, 4D is 5th period and 5D is 6th period. Okay, so now what happens, 14 elements in the 6th period in which the 4F subshell is being filled. So everything is correct, but this atomic number that is given is your wrong here. Okay, next, 14 elements in the 7th period, no, it is a part of 6th period. 14 elements in the 6th period from atomic number 58 to 71 in which the 4F subshells are filled. So this is your definition of lanthanoids. And 14 elements in the 7th period, one second, yes, 14 elements in the 7th period, atomic number 90 to 1, this is the definition of your actinoids. Okay. Next, the total number of inner transition elements in the periodic table are. So if you remember the total number of inner transition elements, so F block elements, okay, F block elements are called as inner transition elements. Okay, D block are transition and F block are inner transition. So F block includes both lanthanoids and actinoids. So here we have 14, here we have 14. So total number of atoms will be 28. Or elements will be 28. Next, lanthanides for which the +2 and +3 oxidation states are common is, so you should remember this one, EU can show +2 as well as +3. +3 though is shown by everyone, +2 is shown by EU because of its stable half filled configuration of 4F7. Okay. Next, the reaction for the stability of gadolinium 3+ ion is, so the reason, okay, so this is the question is reason. So why gadolinium 3 plus is stable? Because of its half-filled 4f7 subcell. Okay, so you can see here I have explained what is the gadolinium configuration. It is Xe4f7 5d16s2. Now when gadolinium is in +3 state, it will lose these 3 electrons, so you will get Xe4f7. Now a half-filled 4f subshell is highly stable due to the exchange energy and the symmetrical distribution of the electrons. So that is why option number A. Next, the pair of the compounds in which both the metals are in the highest possible oxidation state is. Okay, so now if I see the first one, let me calculate. So here you can see Fe is in +3 state, okay, and cobalt here is also in +3 state. I think this is the answer because Fe also has the highest oxidation state as +3 and cobalt highest oxidation state is also +3. Here if I check, chromium is in chromium is in +6 state, the compound in which both the metals are in the highest possible oxidation state. Okay, highest possible oxidation state we have to find, right? And MnO4 is in +7 state. Yes. Let us see the next question here. The pair of the compounds in which both the metals are in the highest possible oxidation state is. Okay, so if I see option number B directly, because I can see chromium and manganese are the elements which has highest oxidation state. So here I see chromium is in +6, manganese is in +7, right? Both of them are in the highest possible oxidation state. So that is why option number B. Here you can see Mn is in +4 state, but its highest oxidation state is +7. Here also you can see Mn is in +4 state, but its highest oxidation state is +7. Okay, so next question number 727. When hydrogen peroxide is treated with cold acidified K2Cr2O7 solution containing ether, a blue color compound is obtained. This is due to. Okay, so if you see the reaction, when potassium dichromate reacts with hydrogen peroxide, it forms chromium pentoxide. Okay, chromium pentoxide, which is exactly blue in color. So what is exactly formed here? Chromium pentoxide, and that is why the correct answer is option number B here. Okay. Next we see question number 28. The catalytic activity of the transition metals and their compound is related to high heat of atomization, variable oxidation states which are interconvertible, high paramagnetic moment values, positive electron gain enthalpies. So it is due to the variable oxidation states, so that it is interconvertible and it helps to make complexes with the elements. Okay. Next, when solid K2Cr2O7 is strongly heated, the products are, so you should remember this one as well. So when you decompose K2Cr2O7, you get potassium chromate, Cr2O3 and O2. Okay, so that is your option number B. So these reaction based questions, so please note down the reactions and you need to revise it. Next, a stronger oxidant among the following is. Okay, stronger oxidant among the following means it will oxidize others and itself it will get reduced, right? Itself it will get reduced. So if you see Mn3 plus will get reduced to Mn2 plus, and you know this Mn2 plus is very special. Why? Because of the stable D5 configuration, right? So Mn2 plus is very stable because of this D5 configuration. So the correct answer for this question will be option number C. Okay. So yes students, these were some of the top 30 questions, and similar questions have been asked in the exam as well. So please do prepare these questions. If you have any doubt in any question, please comment down. I will definitely address to it. Okay. So thank you for watching, and in the next top 30 series, we are going to complete the chapter coordination compounds. So if you haven't revised that chapter, please go revise. And one more thing, we are having our Abhyas test series. Please do purchase it. it is just available now at 1498 rupees. You can get access to 35 mock tests, and these all mock tests comes with a live doubt clarification, video solutions, and you can also, we have just given you a demo last, you can see a video where we have given you a demo how the test series looks. You can see everything about your performance and everything. So please do check out this one. The link is there in the description section. So thank you for watching and see you soon in the next class.